So guys, today we are going to look at something called integration by parts. This is a more advanced integration technique, and yes, I know we're skipping section 7.1. 7.1 is actually kind of a rehashing of some of the integration techniques like you said that we used in this example here. So this actually we can stop, and that's going to give us 0. So our objective here is to find antiderivatives using something called integration by parts, which you are not familiar with. So let's just, actually here, let me jump to the example. How in the world would you integrate that? How would you integrate x sine x dx? Well, based on your current skills, assuming you haven't looked ahead, the answer would be I couldn't do that. You can think u sub, but what would u be? So if you let u be the sine of x, the derivative, there's no cosine. If you let u be x, the derivative of that is 1, and that doesn't really help me because I still got that sine thing, right? Actually, you know what, before I go too far, what operation do you see? So I'm going to just drop this little tidbit here. So if you remember last week, I posted a video on how they came up with the arc length formula, right? Did anybody watch that? Just anybody? Nobody watched it. Okay. You did?
Not yet.
Okay. It's really interesting. It's why I think I encourage you. I'm not going to actually derive the formula, but I'll give you a hint. It's based on what he just said. So here is the formula for integration by parts, and it says the integral of u dv is equal to uv minus the integral of v du. This is what you need to memorize. That's it right there. Okay, good luck. Have a good day. Now I'm going to show you some examples of how to do that. Okay. So the formula is, and I'll write it, I think it's always good to write this stuff down. So if you're going to do the integral of u dv, that's going to be u times v, whatever the heck that is, minus the integral of, and then it's going to be v du. Again, how in the heck that formula came up, I would encourage you to investigate that. I'm actually not even going to post the video on it. You can look it up and find it. And I think there's an explanation in the book as well. Anyways, so here's what we're going to do. And I'm just going to pretend that you know what you're doing and model how I would do this problem. So the first thing I would do is I would recognize that u sub's not going to work here, so I'm going to have to do something else. And this seems like a u sub situation. And if you watch my video, I kind of explain what that is. And what was the formula again? The integral of u dv
minus integral of v du.
Is that right? Did we get it right? Now I'm telling you, you have to get that right or you're going to be in trouble on every problem, okay? And it's not that difficult. So let's go ahead and figure out what we need to do then. If you guys don't mind, I'm going to let u be v, or u be x, and I'm going to let v, dv, be sine x dx. Is that okay? And why'd you do that? I'll tell you more in a minute. Okay, just trust me. For some reason, I took this part and I made it u, and I took this part over here and I made it dv. Okay, great. So, we'll stand for what would du be?
1.
Nope.
Yeah. Oh, yeah.
Thank you. It would be dx. Agreed?
Yeah.
Good. What would v be?
The integral.
Sine or cosine x or negative cosine x?
Negative.
Negative sine x? Negative cosine of x. Okay, so this right here is what I'm now going to plug into this. Yes?
Why do you not need a c when you integrate?
Just don't worry about that. You don't. We'll talk about that in a minute. Let's just go ahead and get through this one and then we'll get back to that. Okay? All right. So this right here is this integral. Okay? We want to know what is the, let's do it in a different color. We want to know what is the integral of x sine x. Now remember, that's u, this is dv, agreed? Yeah. So, what's u? X. What's v? negative cosine of x. Again, I'm leaving off the plus c. He has a good question, and we'll see if we got time to talk about that later. Minus the integral of v. What's v? Negative cosine of x. And then what's du? Okay, moving on. So clearly this first thing is going to be negative x cosine of x. Now I've got to do the integral. By the way, I'm going to change this with a different color here. You guys agree this will become plus and plus, agreed? Now what is the integral of cosine x? Sine x. Kind of part of the reason we're not putting the c in there is because we're doing it now. There is a constant of integration, but we just deal with it later. It's kind of like when we integrate both sides of the equation, we usually just put plus c on one side. Huh. Now I have a question for you. This is the answer. How do you check the answer? By the way, how many of you feel like I don't know that I would have known that was the answer, first of all? How many of you would have guessed that this integral was that? Anybody? I would not have. Can we check? How do we check? Let's check, okay? So let's do the derivative. So let's do a check now. Okay, what's this derivative? We got to do the product rule, right? So we got to do 1d2 plus 2d1, agree? Okay, what's 1? Negative x, derivative of 2. I think it's negative sine x, isn't it? Plus, now I got to do 2d1. What's 2? Cosine of x. Derivative of 1. Negative 1. Okay, now what's the derivative of sine? And the derivative of c. What happens to this guy and this guy? What happens to this negative and that negative? Does x sine x look familiar? When I first saw this, it's like, whoa. And this is one of those things where they basically, I'm just going to let you know, they basically manipulate the product formula for differentiation and you get this. There's so many things in calculus that seem like they're their own little obscure thing, like the mean value theorem. Did you know that's just essentially the fundamental theorem of calculus? Some people actually refer to it as the fundamental theorem of calculus. You can manipulate the fundamental theorem of calculus and you'll get the mean value theorem and vice versa. It's kind of interesting. But somehow, Euler's method and Newton's method, there's just manipulations of basic definitions that we have in calculus. So anyways, comments or questions on that? Yes?
So does this only work on a product of two?
Yeah.
Okay.
Yeah. And I'll give you a hint on when you want to use it, obviously on the homework this week. But in the future, they're not going to say, hey, Alex, do the integration by parts on this one. You're going to have to figure that out. But typically, it's when you're dealing with the product of something that's algebraic and something that's not algebraic. Or it's trigonometric and it's transcendental. It's like two different types of functions, right? You have algebraic functions like polynomial functions, right? You have trigonometric functions like sine and cosine and that kind of stuff. You have transcendental functions like e to the x and ln of x and all. When you get a mix of those two things, that's a good indication you want to do integration of parts. So we're getting a little bit ahead of ourselves, but that's a good question. Okay, here's what I'd recommend you do. Write the formula down. Write the formula down. Because once you got the formula, you're set. Well, I shouldn't say you're set. It's very likely you're set. Agreed? Now, guys, I don't expect you to have that memorized today, but hopefully by the end of the week, you'll have a really good understanding of it. Because I'm telling you, when it comes AP exam time, if you don't know the formula, you're probably going to make a mistake. Now, there are some ways you can cheat if it's multiple choice, right? But anyways, Okay, so can you guess what u is going to be in this problem? Can you guess what dv is going to be in this problem? E to the 8x dx. Can you guess what du is? Can you guess what v is? You got to integrate this. I think it's 1/8 e to the 8x. Right? By u sub. U sub. No u sub. No u sub. Do you guys want to finish it? Can you go ahead and finish this one? I'm going to pause. You might still be working, and that's okay. What's u? What's v? 1/8 e to the 8x minus, what's v? That's that again, right? So it's 1/8 e to the 8x. And then what's du? Dx. Okay, great. So this is just, I mean, you could just write this as maybe x e to the 8x over 8. And then what's the integral of that? Well, it'd be another 1/8, right? E to the 8x plus c. So I think the answer would be, oh, do I want to get a common denominator? Yeah, that might be interesting. So that'd be like 8x e to the 8x, all of this over 64 minus what, e to the 8x? Let's see. That'd be a clean way to write it. It certainly wouldn't be wrong to write it like, you know, what would that be? Another way to write this would be x e to the 8x over 8 minus e to the 8x over 64 plus c. Either one. How do you check it? Let's check it, okay? Let's start with the easy part here. What's the derivative of this going to be? First of all, the derivative of c is 0, right? What's the derivative of that going to be? Well, it'll be negative e to the 8x over 64, but then I have to multiply by 8, right? Okay, good. So that's that part. Now, this part here, what do I have to do? Have to do the product rule, right? So I'm going to do, I don't know how, maybe I'll write it this way. Let's kind of do it here. I'm going to write 1/8 x times e to the 8x. Is that okay? Let's do the product rule on that. Ready? So 1, derivative of 2 is 8 e to the 8x plus 2, which is e to the 8x. Derivative of 1 is, okay, so now we've got, so that'd be 1 over 8 e to the 8x. And then this thing here, which the 8's would cancel, I think, right? So that's going to be plus x e to the 8x. Oh, by the way, this cancels in that, right? I could make this stuff up, could I? And so you're left with this. Good? Okay. All right, let's do one more. Last one is a little bit harder. If you look at the headlines, you can tell why it's harder. This will be a repeated integration by parts. Now, before I do this example, and if you want to work ahead of me, you can. But I just want to tell you that there's two things I need to tell you. But before I do this one, there is a tabular method. I'll just mention that. I'm not going to explain that to you. I didn't explain it to my class last year. I think it's called the tabular method or something like that. It's described in the book, and there's information on it online. If you want to learn about it, you can. I'm not going to discuss it here in class. It's more stuff for you to memorize if you want to memorize it. I don't think it's necessary, so I'm going to skip it. Okay? But it handles this situation. So what we're going to do is we're going to do integration by parts again. Can you guess what u is? Oh, actually, let's be good here. It's the integral of u dv equals uv minus integral v du. Agreed? Okay. So what's u? X squared dv sine 4x dx, du 2x dx, v negative 1/4 cosine 4x. Good? Okay, so I'm going to go ahead and work this one. So let me get a different color here. Let's do some red. So now what I'm doing is I'm going to start substituting this stuff in. So I've got the integral of x squared sine 4x dx. Well, it's going to be u times v, so it's going to be x squared times negative 1/4 cosine 4x. That's the u times v part. Now I'm going to do minus the integral of, and this is a v here, this is the v, so that's that. I'm going to write, I'm going to go ahead and just leave it like that. Negative 1/4, and I'm screwing this up here. Bless you, sir. Negative 1/4 cosine of 4x. And then I've also got to multiply that by what, du. Well, du is this thing, so I got to do 2x dx. So that's going to give me, and I'm not going to be done with this yet, this is going to give me x squared over 4 negative cosine 4x. And then minus and minus makes that positive, agreed? And then this 1/4 and that 2 would become 1/2, agreed? So this is going to become plus 1/2 the integral, and if you guys don't mind, I'm going to write the x first, cosine 4x dx. Do you see a problem, Houston?
You gotta do.
Integration by parts again.
Thanks.
Okay, so this part's all good. This part, not so much. Because again, we've got an algebraic function and a trigonometric function. So let's go ahead and play the game one more time. So let's see here. Can you guess what u is? Can you guess what dv is?
Cosine 4x.
Cosine 4x dx. Therefore, du would be what here?
dx.
Dx. And v would be, I think it's 1/4 sine 4x, if I'm not mistaken. Do you guys agree with that? Okay, so let's do this part still in red here. So we got negative x squared over 4 cosine 4x. Now, I've got to do this part. I'll do it in green. Okay, so this is going to be plus 1/2. Now, in here, I'm just dealing with this part right here. So I'm going to do u times v. What's u times v? Well, that's going to be, let's just put x over 4. That's x over 4, right? 1/4 x. And then sine 4x minus the integral of v du, right? Well, what's v? So that's going to be a 4 sine 4x and then dx. Whew, okay. So things are getting a little nasty. I don't know if I've got another slide here. No, I don't. Okay, I'm going to have to go off the board here a little bit. What time is it?
10:04.
Okay, good. We got time. Okay, so now I've got negative x squared over 4 cosine 4x. And then I've got, so that first part there, I think that'd just be x over 8. Wouldn't you agree? X over 8 sine 4x. And now I've got to integrate this guy here. Now don't forget, we have that 1/2 in the front still too, right? So I think the integral of sine 4x would be negative 1/4 cosine 4x, agreed? So that means we've got a 1/2 times a negative 1/4. I hope I don't screw this up. And I think I said it'd be a negative 1/4 again of cosine 4x. Did I say that kind of correctly? You got to be really careful because we're kind of got nested stuff going on here. So I think negative and negative is going to make that positive. So that looks like 32 maybe, right? So this integral is negative x squared over 4 cosine of 4x plus x over 8 sine of 4x. And then I hope I didn't screw this up, but I did it before class, so I can check. Thanks. I'm going to go ahead and, actually there's one, I'm going to pause this. There's one more video. Okay, so we got that last problem. I want to mention one more thing. Exit out of this. I'm going to keep that for now. And I'm going to go to this. And I want to mention this. This might be something, actually, I'm going to encourage you to write this down. And this is lame, but it works. Almost always. In fact, I don't think it appears to me. I'm going to just tell you right now, I kind of wasn't a great teacher right then because every example I did involved basically an x of some sort and then a trig function, right? Guys, it doesn't have to be that. It could be combinations of different things. And this little phrase, which I will lovingly refer to as liate, which by the way is not French. Last year I think we made this up. Liate. This stands for log or logarithmic. This stands for inverse trig type of stuff. This stands for algebraic. This stands for trig. And then this stands for exponential. And what I'm telling you is this. Let me write down the example that we did in class. The very first one I think we did, wasn't it x sine x dx? This is the integral. You go through these letters, and the first one you see that's in this is what you let x be. So when I go through this, let's see, are there any logs? Nope, no logs. Are there any inverse? Nope, no inverse trig. Is there an algebraic one? Oh, yes, right there. That's why I let x or u equal x. Now, I'm not going to spend time practicing this with you, but if you had a different problem that didn't have an algebraic term, but like Alex mentioned, it was a product of something, and maybe it was a logarithm and a trig. Maybe it was something like, and guys, I don't know if this will even work out well, but if it had been the logarithm of x, cosine x, let's say, that might be fun. That might work out, probably will. Guess what you would let u be? The ln of x. You with me? Liate. Got it? That's integration book parts.